Hello all, let's start our chapter 2 lecture. And first point and 2.1 I will cover for you trigonometric functions of acute angles. Please look at to the right side of the screen. You see I already draw an angle, an acute triangle, which is ABC. You can see it. And in this angle, I can say for you that angle A, which is this angle, if I wanna kinda mark it for you, this angle, angle A, is an acute angle. Also, if you see to this diagram, angle B is also acute, correct? Angle B is also another acute angle. In this section, we go very fast over the trig functions of angle A, what they are. Then after that, we will start with one example which relates angle A to angle B, and I will explain a new topic for you, correct? Let's start with the trig functions of angle A. I can say sine of, let me change the color to black, sine of angle A, sine A, equals opposite, which is y, over hypotenuse, which is r, correct? Cosine of angle A equals x over r, adjacent over hypotenuse. Tangent of angle A equals y over x, opposite over adjacent. And the three reciprocal functions for sine is cosecant A, which is the reciprocal of sine, you can write r over y. Secant of A, reciprocal of cosine, r over x. And cotangent of A, reciprocal of sine, of tangent, you can write x over what? Over y. Now, keeping this in mind, we can do some examples here, and after that, I'll do one example, and after that, I'll explain a new topic for you, correct? Example number 1. Find the sine, comma, cosine, and tangent, values for angle, for the angles A and B. A and what? B. They give you a diagram here, a right triangle, which is in this shape. I try as much as possible to draw straight lines because I have this electric pen. Here you have A. Here you have your B. This is triangle ABC, correct? Of course, here it's 90 degree. The length of this side is 24. This side 7, and this side is how much? 25. First, they are asking you to find three trig functions for angle A, for this angle. For angle A, the important part is to always understand which side is opposite, which side is adjacent, And hypotenuse, to be honest, always is hypotenuse because it's in front of C. Correct? For angle A, 24 will be adjacent and 7 will be opposite. Correct? Then I can write sine of angle A equals opposite over hypotenuse, which is 7 over 25. Cosine of A adjacent over hypotenuse, which is 24 over 25. And tangent of angle A equals 7 over 24. I'm done with angle A. Now, they also ask you to find the trig functions for angle B, which is also an acute angle. I use green color. Remember, for B, this side, which is 24, becomes opposite, and this side becomes what? Adjacent. Hypotenuse stays the same. If you understand this much, it's then really easy. Correct? Now, sine of angle B equals opposite, which is 24 for angle B, over hypotenuse 25. Cosine of angle B equals adjacent, which is 7, over hypotenuse 25. Correct? And tangent of angle B equals opposite, which is 24, over adjacent 7. Now, I want you to focus for this three trig functions for angle A and 3 trig functions for angle B. You will see something that some of them are equal. You see, sine of angle A, which is 7 over 25, actually equals to cosine of angle B. Cosine of angle A, which is 24 over 25, equals to sine of angle B. Correct? And if I write cotangent for both of them and secant and cosecant, that will be a kind of relation between these two angles. From here, I want to talk about something else. What is this relation actually? What does it mean, this relation actually? Correct? We have functions that we call those functions co-functions. Correct? What is first co-function? Oh, let me change the color again. It's green, black. What is co-function? There is a relation between trig functions we call sine and cosine co-function of each other. They're like ordered pairs, correct? The same way, cosine and sine are co-functions. Sine and cosine, they're co-function of each other. Tangent and cotangent, they are co-function of each other. Secant and cosecant, they are the co-functions of each other. Correct? From here on, I want to tell you a few things. First, few small notes that's really important for you to understand, correct? F 2 acute angle are complementary if you have two acute angle, let's even name them A and B, correct? Are complementary, then these relations are working very well. What relation? Sine of angle A will be equal to the cosine of its complementary. Because I'm writing in general form, it looks kind of weird for you, the notation, but the meaning is this. Sine of angle A, whatever angle is, equals to the cosine of its complementary. It means cosine of 90 minus A. Cosine of its complementary. Correct? Cosine of angle A equals to the sine of its complementary 90 minus A. Tangent of angle A equals to the cotangent of its complementary 90 minus A. Correct? This relation between two complementary angles are always working very well. That's why I put these definitions for you up there. Let's focus on them and let's do some easy examples. But the actual meaning I'm explaining again and again to you, that the meaning is if you have two complementary angles, the sine of one of them equals the cosine of the other, and the cosine of the other one equals to the sine of the other. Correct? That's the whole idea behind these definitions that I just put for you. Correct? Let me find some good examples for you. Example number 1. Write each function. Write each function in terms of its co-function. Its co-function. Correct? Part A, cosine of 52 degree. I want to write this function in terms of its co-function. First of all, equal sign. What is the co-function of cosine? Of course, sine. Now, parentheses, If you see, I want to even explain this example for you in a diagram. If you have a triangle like this, if one of the angles are 52 degrees, correct? This is 90. How much is this? You have to find this. If I name this angle A, this angle B, A plus B always gives you 90, correct? Because if I go this way, A plus B plus C gives me 180. If one of them is 90, the other two should give me immediately 90. And if they give me 90, it means they are complementary, correct? That's why I say cosine of 52 degree equals whatever the other angle is, 90 minus what? 52. And if I subtract from 90, 52, it gives me this angle, whatever this angle is, correct? Then I can say equals to sine of, I think 38, right? 38 degree. This angle is 38 because 38 and 52 gives you 90. Correct? Part B. Tangent of 71 degrees. What is the cofunction of tangent? Cotangent. Here, 90 minus what? 71. Because we want to find the other angle, correct? Then cotangent of how much? 19 degrees. Part C. Secant of 24 degree. Then this one equals the cofunction of secant is cosecant. Of which angle? 90 minus 24. Which gives you cosecant of 66 degrees. That's it. That's easy. The important part, because soon at the end of this lecture you will see the relation between complementary angles. Just remember, sine of one complementary angle equals to the cosine of its complement. Correct? Next example. Find one solution. Find one solution for the equation assume all angles involved, it means involved in this equation, are acute angles. Are acute angles. The equation is given to you. What is the equation? The first example, I think here, first example. Cosine of parentheses theta plus 4 degree equals sine of 3 theta plus 2 degree. Now, how to solve this equation? Few things. Focus here. I have cosine equal to sine. It means this relation represents cofunctions. It means also that this angle, this is an angle, theta plus 4 is one angle. This angle is the complementary of this angle, 3 theta plus 2. Based on the complementary relation, can I write theta plus 4 degree? If I add this angle with another angle, which is 3 theta plus 2, it should give me how much? 90, because they're complementary. Here you go. Very simple equation. Solve it for theta. Theta plus 3 theta gives you 4 theta. 4 degree plus 2 degree gives you 6 degree. Equals 90 degree. Subtract 6 degree from both sides. Then you can write 4 theta equals what? 84 degree. Divide both sides by 4. Theta equals 21 degree. Here you go. You found your theta. How much is your theta? Okay. This is the solution for your equation. If you want to see, let's check. This is not part of the problem. They are not asking you. They just ask you to find the solution. But do you want to check if these two angles that I underlined with green and blue, they are complementary to each other? Plug in 21 here. It gives you 21 plus 4, which gives you what? 25 degree. And if you plug in the blue, it gives you 3 times 21 plus 2, which gives you 3 times 21 is 63 plus 2 gives you 65. Is 65 degree and 25 degree, they are complementary to each other? Definitely yes, because if you add them, it gives you 90. Did you see how it works very well? Example number 2 or 3, I don't know. Example number 3, you just count. Same thing. Tan theta, it's an equation given to you. Tan of 2 theta minus 18 degree equals cotangent of theta plus 18. First of all, can I make that equation? I have to focus on few things. Tan on this side, cotangent on this side, co-functions. Yes. Correct? It means this 2 theta minus 18 is the complementary of theta plus 18. These two, the relation between these two angles is what? They are complementary to each other. Even I'm writing here for you. Now, relation between the complementary angles, if you add them, they are equal to what? 90. Then I can write 2 theta minus 18 degree plus theta plus 18 degree equals what? 90 degree. 2 theta plus theta gives you 3 theta. Correct? Negative 18, positive 18 cancels out, equals 90 degree. Divide both sides by 3, then your theta equals 30 degree. That's it. You solve another equation. The next topic that I want to discuss here, I'm talking about, in this part of the lecture, increasing. Still we are in 2.1. Increasing, decreasing, functions. I will try to draw, that's really a bad drawing. I'll try to draw three right triangles here for you. Correct? This is triangle A, angle A. Let's say, just name the angle. This is angle A. Of course, this is your X, this is your Y, and this is what? Your R. Now, I will increase in the second diagram the amount of A. Correct? Bigger angle. This is your A. Again, this is X, this is Y, this is R. And the third one, I'll increase it more, but still try to keep acute. Correct? This is angle A. X, Y, R. Now, which trigonometric function is an increasing function? Which trigonometric function is a decreasing function? Correct? Let's say, let's look, let's kind of think carefully. I will write sine first, correct? Sine of angle A here for me equals opposite, which is Y over what? R. Now, as I increase the angle, as A is getting bigger, in the second picture, you see A is getting bigger. What will happen to Y? The length of the Y is also increasing. Correct? As A increases, the length of Y is increasing. Correct? Then I can say sine of A is always what? Increases. Look at the cosine. As A is growing bigger, the length of cosine is decreasing. Why decreasing? Because the our hypotenuse is changing, Y is changing, but A is kind of constant. Your X is kind of constant. It's not changing, correct? If it's not changing, look at, there is a relation in functions, in fractions. If I have A over B, correct? As A increase, if your numerator gets bigger and bigger and bigger, correct? Possibly the number is growing bigger and bigger, bigger. Your outcome is growing bigger, 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 and bigger. Correct? Your denominator, which is B, is actually here X. Correct? Now, I will write the second relation. Cosine of A decreases. Tangent of A, and of course tangent increase because it's sine over cosine, correct? Because sine is growing big, then tangent is also increasing. Okay, if I know this three relation, I can talk about cosecant, which is the reciprocal of sine, correct? Then cosecant of A is also increasing. secant, which is the reciprocal of cosine, of course decrease. Correct? Sorry. A mistake. If sine increase, correct? The reciprocal of sine definitely decreases, correct? It's opposite. If cosine decrease, its reciprocal increase. If tangent increasing, then cotangent decreasing. Correct? This is how we talk about, of course, just here, but later on when we move to the next chapter, even in graphs, you see which one is increasing, which one is decreasing. But here, for time being, this is how the way that we explain for you which function is which trig function is increasing, which one is decreasing. Correct? I'll try to make this lecture in 2 videos because the second part right now that I want to talk about is totally something different. I will stop the lecture here. I'll make another lecture as a part 2 for section 2.1.